So the next thing we're going to talk about is how to simplify rational expressions. Remember, rational expressions are just anything that can be expressed as a fraction. So the steps that we're taking here are actually the same steps we would take if we just wanted to simplify a fraction. So for example, if we wanted to simplify the fraction 8 over 10. First step would be to factor the numerator and the denominator. So we've learned how to do that. So if we wanted to factor 8, we could do 4 times 2. And if we wanted to factor 10, we could do 5 times 2. And obviously 8 is not factored all the way, but in this case it's not going to matter. But that's step 1. We factored the numerator and the denominator. Our second step is to cancel out any common factors. So they share a common factor, and it's 2. There's a 2 here, there's a 2 there, and those will cancel out. So that leaves us with 4 over 5. And hopefully you know how to do that. Simplify 8/10 and get 4 over 5. Sorry, drink of water really quick. Okay, so there we canceled out any factors. This third step doesn't apply to fractions. I'll show you the third step here in an example I'm going to do with an actual rational expression. So the difference between a fraction and a rational expression is a rational expression involves variables. There's a variable in there somewhere. So let's say instead of simplifying 8/10, let's say we wanted to simplify 8x squared over 10x. Okay, so we do the same thing. First, we'll factor the numerator and the denominator. If we want to factor 8x squared, we could do 4 times 2 times x times x. And if we wanted to factor the denominator, we could write it as 5 times 2 times x. So there's step 1. Factor the numerator and the denominator. Our second step is to cancel out any common factors. So we've still got these 2's, those will cancel, and now we have a set of x's that will also cancel. And we're left with 4x on the top and just a 5 in the denominator. So that was step 2. We canceled out any common factors. So step 3 says set the original denominator equal to 0 and solve. And that will give us the excluded values. So we need to take our original denominator, which is 10x, and we need to set it equal to 0. 10x, set it equal to 0. And then solve. So here, pretty simple to solve. Divide by 10, and x is equal to 0, because 0 divided by 10 is 0. Okay, I'm not sure why that keeps doing that. So the reason we set the denominator equal to 0, the reason we do that is because the denominator can never equal 0. So we need to figure out what value of x will make the denominator 0. That's why we set it equal to 0. Because if 10x is equal to 0, that means we're dividing by 0, and we can never divide by 0. Remember, if you put it into your calculator, anything divided by 0, you can't do it. It'll say error, because we can never divide by 0. So we have to do that. We have to take that step. We have to set the original denominator equal to 0 and solve, and that gives us the excluded value. So the way we write our final answer here is 4x over 5, where x is not equal to 0. That's our final answer. So first we factor the numerator and the denominator, then we cancel out any common factors, then we set the original denominator equal to 0 and solve, and that gives us the excluded values. Only the denominator. We don't set the numerator equal to 0. Just the denominator, just whatever's on bottom cannot be 0. The top can be 0 because we can divide into 0. We just can't divide by 0. So with that in mind, let's do a slightly more involved example. So this says, try to zoom out just a little bit. Okay. So this says, what is x squared plus 7x plus 10 divided by x squared minus 3x minus 10 in simplest form? And then to state any restrictions on the variable. So our first step was to factor the numerator and the denominator, or basically factor. All right, I'm not going to write out the steps again, just because it'd be too long. Factor the numerator and the denominator. So come down here, and our numerator is x squared plus 7x plus 10. So this is a trinomial because it's got three terms. Remember, when we want to factor a trinomial, we set up our little table, addition, multiplication. We're looking for something that adds to be 7, remember whatever our middle coefficient is, and we're looking for something that multiplies to be 10, whatever our constant is. And those two numbers are 5 and 2, right? 5 plus 2 is 7. 5 times 2 is 10. If you couldn't think of that off the top of your head, you could list the factors of 10. So 1 and 10, 5 and 2, and you'd hopefully figure out that 5 plus 2 is 7. So then we can bring that over here and write that out as x plus 5 times x plus 2. And that's our factored form. We also need to factor the denominator. So we'll have x squared minus 3x minus 10. Set up our table for this one. Looking for something that adds to be negative 3 and multiplies to be negative 10. That's also 5 and 2, but this time the 5 has to be negative, right? Because the 3 is negative and the 10 is negative, so negative 5 plus 2, negative 5 times 2. And this is a review, that's why I'm going through this so quickly. This will be x minus 5, and this will be x plus 2. Okay, so then our sort of answer that we get out of this is x plus 5 times x plus 2 is our numerator. It's our factored form of our numerator. And our denominator, we got x minus 5 times x plus 2. So notice we didn't change the problem. We didn't do anything different. We just factored. So just like up here, we rewrote 8 as 4 times 2. Down here, we just rewrote x squared plus 7x plus 10. We rewrote it as x plus 5 times x plus 2. That's all we did. We just factored it. So then our second step is to cancel out any common factors. This x plus 2 will cancel out. That's a full factor that's in both, x plus 2. So then, simplified, we have x plus 5. X plus 5 divided by x minus 5. I can't simplify that any further. The x's don't cancel. The 5's don't cancel, and that's because they go together. If you want to leave your parentheses to keep that clear, you can. Doesn't matter. But we can only cancel out full factors. We can't cancel out anything that's being added or subtracted to something else. We can only cancel out things that are being multiplied because those are the factors. Okay, so now we need to do step 3. Step 3 said set the denominator, the original denominator, equal to 0 and solve to get the excluded values. So we factored our denominator right here. That's this denominator factored. So if we were going to set this original denominator equal to 0, the first step we would do is factor it. So we've already done that step. So we just set this equal to 0. X minus 5 times x plus 2. We set it equal to 0 and solve. And we know how to do that. We just set each factor equal to 0, because if either one is equal to 0, the whole thing has to equal 0. So then add 5 to both sides, x is equal to 5. Subtract 2 from both sides, and x is equal to negative 2. That gives us our excluded values. Just like up here, this gave us, in this case, only 1, but it was our excluded value. So we can have as many excluded values as come up, but down here we have 2. X can't equal 5, and it also can't equal -2. So then our final answer, just to write it succinctly, is x plus 5 over x minus 5, where x cannot equal our 2 excluded values, 5 or -2. And that is our final answer. So this kind of wraps up, this is kind of the basic steps of how to simplify rational expressions. I would write those steps down, maybe copy down these examples if you didn't as you watched, so that you'll be able to do this on your own as I give you some problems to work out. There's sort of a big view of the more involved problem that we did.